Jaborandi or Pilocarpus pinnatifolius refers to a 3 or 7 meter high shrubby tree with a smooth grey bark, large leathery leaves, and thick, small, reddish purple flowers. The use of this plant is parasympatomimetic. It has been used widely as eye drops to treat glaucoma and also used as a hair tonic, which is believed to open pores and clean hair follicles, prevent hair loss, and generally aid in the manageability of hair. It is widely used in Brazil to treat asthma, bronchitis, diabetes, urinary insufficiency, and also to promote perspiration and salivation. The main active constituent in this Jaborandi plant is pilocarpine, which is from imidazole alkaloids group. Little did you know, imidazole alkaloid is widely used in oil and gas industry. Okay, before I go to the application of imidazole as corrosion inhibitors, let me tell you what is the mechanism of inhibition. The inhibition of carbon steel corrosion by imidazole compound is due to the adsorption of the inhibitor molecules on the metal surface. Imidazole molecule shows 3 different anchoring sites suitable for surface adsorption, which are the nitrogen atom with its lonely sp2 electron pair, the active hydrogen atom attached to the nitrogen atom, and the pi bond of the aromatic ring. Most of the organic compounds containing nitrogen atoms have an electron donating ability and could be adsorbed by electron donating of the nitrogen atom and by bridging with the active hydrogen atom attached to the nitrogen atom. On the other hand, the pi bond of the aromatic ring is considered as the center for adsorption process, in which the great adsorption of some organic compounds is attributed to the interaction of the pi electrons with surface atoms of the adsorbent. Thus, it is reasonable to assume that the imidazole molecule is adsorbed onto the carbon steel surface in a flat orientation through a monodecade form. The flat model for adsorption is stable and preferred since the covered fraction surface is high even at low inhibitor concentration. The extraction of compound from Jaborandi can be done by using chocolate. First of all, prepare the sample by collecting the leaves of Jaborandi. Moisten the sample with 10% of sodium hydroxide. After 15 minutes, carry out extraction for 3 times with chloroform by using chocolate. The pooled organic extracts are then re-extracted twice with 2% of sulfuric acid. The pooled acid extracts are then adjusted to pH 12 with ammonium hydroxide and then extracted twice with chloroform. The organic extract was dried in a steam vacuum and dissolved in 10 ml of solvent A prior to injection. Solvent A is composed of 0.05 ammonium acetate buffer adjusted to pH 4 with 3 fluoroacetic acid. Then, the separation of compound, including imidazole, can be done by using HPLC. Finally, electrospray ionization mass spectrometry is used to detect the presence of imidazole from the extraction. So, why do we use corrosion inhibitors? Oil industry is facing severe corrosion problem and cost the oil and gas operators millions of dollars worth of damages. These damages are due to acidization of petroleum well. However, acidization of a petroleum well is one of the important stimulation techniques for enhancing oil production. Hydrochloric acid is generally used to enhance the oil production by improving the well's productivity or injectivity. Oil and gas operators have used acid treatment to improve well production for almost 120 years. Acidizing predates All other well stimulation techniques, including hydraulic fracturing, which was not developed until late 1940s. 15% to 28% of hydrochloric acid is pumped into a wellbore or geologic formation that is capable of producing oil and gas. Hydrochloric acid may remove the plugging in the bore well, hence increasing the flow of the oil. However, until the early 1930s, acidizing use was limited by the lack of effective acid corrosion inhibitors to protect the steel tubulars in the wells. With the development of effective corrosion inhibitors, the use of acid treatment proliferated. What do corrosion inhibitors actually do? Corrosion inhibitors aim to delay the reaction between metal and corrosive species. Corrosion inhibitors act by absorbing either ions or molecules onto the metal surface, thus reducing the corrosion rate by blocking the anodic or cathodic reactions. Inhibitors are added into the acid solutions during acidifying process, which is intended to reduce the aggressive attack of the acid on tubing and casing materials, which were made of N80 steel. Most of the well-known acid inhibitors are organic compounds containing nitrogen, oxygen, and sulfur atoms, heterocyclic compounds, and also pi electrons. The polar function is to establish the adsorption process. Organic molecules inhibit corrosion via adsorption at the metal solution interface, resulting in formation of adsorption layer as a barrier, hence isolating the metal from corrosion. Is imidazole a good corrosion inhibitor? Plant extracts are excellent alternatives as inhibitors because of their availability and biodegradability. The extracts are generally obtained from cheap solvents that are widely available at a low cost and with low toxicity, which in this case is Jaborandi, to extract imidazole. Imidazole derivatives have been reported as non-toxic for copper in acid media. Imidazole is also highly stable and has good solubility, thus it is widely used. In 2001, 3 long-chain fatty and oxodiazoles, namely U-mode, H-mode, and D-mode, were synthesized by Corrosion and evaluated as corrosion inhibitors for mild steel in 15% hydrochloric acid at 105 degrees Celsius by weight loss method. Inhibition tests were also carried out on N80 steel under similar conditions in 15% of hydrochloric acid containing 5,000 parts per million of U-mode, and the results obtained indicated that imidazole derivatives are good corrosion inhibitors. U-mode was found to be the best corrosion inhibitor because it inhibits 94% inhibition efficiency for N80 steel and 72% inhibition efficiency for mild steel.